All right, this is Chapter 2, Lesson 2. Make sure you write 2.2 on your paper and today's date. I will be looking at your notes tomorrow when you come into third period, so please make sure you take your notes today. Today's objective is to simplify numerical expressions by applying properties of rational numbers and justify the process used. That means you have to basically simplify expressions by combining like terms, and then you have to basically just say what you did. That's how you justify the process. The vocabulary for today: identity property of addition. The sum of a number and 0 is the number. So the identity property of addition is 0. Go ahead and just write the objective and the vocabulary down, please. Vocabulary. And of course the objective. Okay? So next. The identity property of multiplication. So the identity property of addition is 0. The identity property of multiplication is 1. That means any number you multiply by 1, you're still going to get the same number. So like 4 times 1 is 4, 10 times 1 is 10. You're not changing the number by multiplying it by 1. Okay? Just like you're not changing the number by adding 0. Whatever you can do to a number and keep it the same, don't change it, that's an identity property. Okay? So write this down. Vocabulary. You don't have to write vocabulary. Sorry, I shouldn't have done that. Here. Okay. And okay. Property of multiplication. The product of a number and 1 is the number. So 8 times 1 is A. 4 times 1 is 4. Example 1. Combining like terms. All I want you to write here is, you know what, write it. Just write example 1, combining like terms. This is what we have to remember. And I noticed yesterday on the test that some people made a mistake and put, or today on the test this morning, 2a plus 6 is 8a. Well, no, you can't add those because they're not like terms. So we need a review on this. We need to make sure we really got this down, that we can only combine terms if they're alike. So combining like terms and this. Simplify b plus 2 plus 5b. So the only like terms on here are going to be b and 5b because they both have b. Okay, so those are the only two that you can combine. So we're going to combine b and 5b, and when you have b, you have, okay, is the same as 1b. When you have b, it's the same as 1b. So I can add 1b plus 5b because they both have the letter or the variable b. So 1b plus 5b is 6b, which is how I got this here, 6b plus 2. Okay? Now, I have to justify the process used. What process did I use? Well, putting the 1 in front of the b, that's the identity property of multiplication because I am not changing the letter b by just simply placing a 1 in front of it. B alone is the value of b. 1 times b is still the value of b. So by putting a 1 in front of it, I'm using the identity property because that doesn't change the value of b. Okay? So 1b plus 5b is 6b and plus 2. And I change the order using the commutative property of addition. So I switched the order by moving the 5b where the 2 was and the 2 where the 5b was. So that all of my like terms are together, making it much more simple for me to add them together, making sure I don't miss any. Okay? Next. On this one, I just want you to write a perimeter of the pentagon and draw a picture of the pentagon. Okay? Don't forget to label each side with the value for that side. So the top two portions are x plus 3, the side two are 2x, and the bottom is x. To find the perimeter, we simply add all the sides. So even though you still have to write this, x equals 3, okay, we're not going to worry about that yet. I don't want to do substitution yet. First, we're just going to worry about adding all those sides together, okay? So, adding all the sides together, I have x plus 3 here, x plus 3 and x plus 3, I have it 2 times. So I can use the distributive property to add these together by saying I have 2 of them, which is where I got this. 2 times x plus 3 because I have 2 of them. And then the next one, how many of the 2x's do you have? Again, 2 of them. So I use the distributive property here by saying I have 2 of 2x. And how many do I have of just x? I have just 1. So plus x. So this is, I've used the distributive property here. And watch, I'm going to show you what it looks like without using the distributive property so that you can see that this might be a little confusing without it. So if I wrote x plus 3 plus x plus 3 plus 2x plus 2x, and I'm not even done yet, right? Plus x. I mean, that's really long. So you're much better off just writing it with the distributive property, which is why we did it this way here. Okay? So now I'm going to use the distributive property to solve it. Remember, I'm going to multiply 2 times everything in parentheses. And remember, multiply, not add, multiply. So 2 times x is 2x. 2 times 3 is 6. 2 times 2x is 4x. And 2 times x, I'm sorry, that doesn't get distributed, my mistake, sorry. No. And just x by itself, okay? You're just distributing the 2 to what's in the parentheses, not what's outside the parentheses. That was my mistake. Now I can combine like terms. In order to do that, though, I want all of my x's together. So now I'm going to use the commutative property of addition to make sure all of my x's are together, okay? So, I change, you're going to write this too. So I change the order of them. So I have 2x plus 4x plus x plus 6, and that's a commutative property. And you should have already written this too, that you use the distributive property for that. So 2 plus 4 is 6, plus don't forget you have a 1 here. So 2 plus 4 is 6, plus 1 more is 7. That's where I got my 7x. And my 6 stands alone because it's the only one that's a constant term on there. All the other ones have variables. Those are variable terms. This is the only one that's a constant term, no variable. So it continues to stand on its own here. Okay? So we combined like terms. Combine like terms. Now I substitute the x for 3. Remember you had on the previous page that x equals 3? X equals 3. So now I substitute here my x for the number 3. Now I have multiplication and addition. What comes first in the order of operations? You should have said multiplication. So multiplying 7 times 3 is 21, and adding 6 is now 27, giving you the answer, simplifying 27. Next screen. Alrighty, guided practice. Here we go. You're going to simplify the expression by combining the like terms. Don't forget to write on here, guided practice, and what we're doing. So remember we have that visible 1 in front of this x. So 3x plus 1x is 4x. That's your answer. 4x. Number 2, I'm going to use the commutative property to change the order here. So my 2a, I'm leaving first. Then my constant terms I want together. 3 and 7 I want together. And again, that was the commutative property. Then I combine like terms. So I have 2a plus, what's 3 plus 7? 10. Again, combine like terms. Okay? Here, I'm going to use two properties. I'm going to use my identity property of multiplication for that y that's standing all on its own to put a 1 in front of it. And I'm going to switch the order of this so that my x's are together, my y's are together, and my constant terms are together. And in math, you always want to put them in alphabetical order. So since in the alphabet x comes before y, I'm going to make sure that x comes first, then y. And then at the very end is going to be my constant term, which is the term without a variable. So, again, I'm going to put a 1 in front of this y, write everything else the same, and that is the identity property. Then, I'm going to change the order using the commutative property. I want my x first. I'm done with that one. Now I want my y's. I have my 1y. Then I also have my 3y. Now, last, I want my constant term, 4. Now I will combine like terms. Combine like terms. So, 2x plus 1 plus 3 is 4y plus 4. Okay, that's your answer. Here, I'm going to first use the distributive property on this. So, 2 times x is 2x. 2 times 8 is 16. So that was distributive property. I'm going to start abbreviating here, distributive property. Now I'm going to use the commutative property to change the order in which my terms appear. I want my variable terms first, so that's my x. My constant terms, 5 and 16, last. Now I'm going to combine like terms. So my 2x stands alone. 5 and 16 is 21. There's my answer. Next. Whoops. All right. This one's easy. Just combine like terms because they both have the variable r. And in both terms, r is raised to the second power. So since they're the same, I can just go ahead and add the coefficient. And just to remind you, this is the coefficient, and this is the other coefficient. A coefficient is a number that's next to a variable. Okay? So I'm just going to add 2 plus 5 is 7. Keep the r squared the same. That's my answer. And remember, you can only do that if both variables are raised to the same power. So if one of those was being raised to the third power, I could not add those together. Here I'm going to use distributive property first to multiply 5 times A and 5 times B. Plus 2 times A and 2 times B. Okay? Now I'm going to use, so that was distributive. Now I'm going to use the commutative property to change the order of these. So commutative property. I want my A's first because A is first in the alphabet. So my 5A and my 2A, done with those. Now my 5B and my 2B, done with those. Now I can combine like terms. So here I have 5 plus 2, adding the coefficients, 7A. And 5 plus 2 again, 7B. I cannot combine these because A and B are different variables. So I have 7A plus 7B. On this one, I have to write an expression for the perimeter, simplify, and evaluate when x equals 2. So let's start. There's a lot of instructions here. Let's do the first one. Write an expression for the perimeter. Okay. Perimeter is when you add all the sides together. So now I know I'm going to be adding 2x and 2x and 2x plus 3. So I'm adding 2x and 2x and 2x plus 3. Well, my goodness, I have 3 2x's here, so I could just 3 times 2x, because I have 3 of them. 1, 2, 3. And I'm going to add 3 at the end. Okay? So that's my expression. Now they want me to simplify it, so I'm going to use the distributive property to simplify it. 3 times 2 is 6x plus 3. Now my last instruction is to evaluate. Evaluate when x is 2. So I have to substitute the x here for the number 2. Okay? So substituting, 6 times 2 is 12, plus 3 is 15. And so we have 6x plus 3, just like I put here, and the answer 15 towards the bottom. Okay, I think there's one more. Yep, last one here. So on this one, same thing, you're going to find the perimeter. Remember, when we find perimeter, we are adding all the sides. So I can see that I have 2 of these 3x's. So since I have 2 of them, I'm going to use the distributive property here and say 2 of 3x. Plus, adding the next sides, I have 2 of the same sides here as well. 2 of x plus 5. 2 of x plus 5. And the last one is by itself, 2 times x plus 1. We're going to add that also. 2 times x plus 1. Okay, so let's use distributive property here first. 2 times 3x is 6x, plus 2 times x is 2x, plus 2 times 5 is 10, plus 2 times x is 2x, plus 2 times 1 is 2. Now I'm going to use the commutative property to change the order of these so that all of my variable terms are together. In other words, I want all of my x's together. So here I have 6x, I have 2x, and over here I have another 2x. So we're going to switch the order and put that down. Now I'm done with all my x's. I have 10 and 2 left. So 10 and 2 come at the end here. And now I can combine my like terms. So I have 6 and 2 and 2, which is 10x, plus 10 and 2, 12. Now you're going to substitute the x for 3. Remember, we said x equals 3? So since x equals 3, I now have to substitute this x for the number 3. 10 times 3 is 30, multiplication first, then addition. 42. So the answer is 42, and the expression you should have written is either this one or this one. And now you're done. Make sure you're ready to show me these notes tomorrow. I need to look at them every day now. Thanks, you guys have a nice night.